Well, great. Welcome everyone to another Best Paper interview from River Publishers. Today I'm with Anand Prasad, the editor-in-chief of our Journal of ICT Standardization. And today we are announcing and discussing one of the best papers from 2021, which was awarded to the paper Authentication Mechanisms in the 5G System. We have some of the authors with us to chat about the paper and authentication mechanisms in general. But to start with, Anand, could you please introduce the journal a little and what it covers?
Sure. So thanks, Philippa, and thanks to the authors for being here. So the Journal of ICT Standardization, actually, I was just checking, it is a little bit more than 9 years old now. So we are getting close to 10 years now. As you know, standards are very important for any field. It helps the society in many different senses, bringing solutions and products out in mass, so by different people, and thus reducing the price. Just think if we wouldn't be able to have this kind of video calls from many different technological perspectives if standards were not there. So Journal of ICT Standardization takes care of that, brings this standards related knowledge to everyone, from pre-standard technologies that could become standards in overall ICT field, to those that are standardized, so deep technical stuff, as well as tutorial standard papers on what standards are for, and then how standards works, things like that as well. So a variety of information is published in Journal of ICT Standardization to bring awareness and knowledge about standards to people at large.
Okay, thank you, Anand. Thank you. Welcome everyone else. So the authors of the paper, thank you for joining me and congratulations on winning the best paper from 2021. Just to start with, could you please all introduce yourself and the paper a little bit?
Okay, who starts first?
Yeah, thanks. I'm Xiaoting Huang from China Mobile Research Institute, and now working as a standardization engineer, focusing on the security aspects of the telecommunications network. I've been an active participant of several standardization organizations in the industry, like 3GPP, ITU, NGMN, etc. And now I am also the lead of the security competence team in NGMN. It's really a great honor to get this Best Paper Award, and thanks for having me here.
My name is Takahito Yoshizawa, and I'm a researcher at the university called KU Leuven in Belgium. And I have been in this academic environment for the past about 3 years now. But before that, I spent many years in industry designing and developing mobile systems products, and also involved in standardization 3GPP for quite a long time also. Thank you.
Hi, this is Sheeba. I work with Lenovo Motorola Mobility as an advisory researcher, and I majorly contribute to Lenovo wireless research, especially for the telecommunication security related standardization activities and various initiatives. So very specifically, I take care of activities related to 3GPP, NGMN, NextG, as well as HC activities that are related to security. And I'm glad to be part of this discussion here with you all. Thanks.
Great. And the title kind of says a lot with it being about authentication mechanisms in the 5G system. Perhaps Xiaoting can talk a little bit about what the paper covered and kind of how it came about.
Sure. So we all know that basically in 5G there have been several authentication mechanisms specified by 3GPP so far, including primary authentication, secondary authentication, slice-specific authentication, and ACMA, which is authentication and key management for applications. So for the industry, maybe they not be fully aware of the purpose or the usage of these various authentication mechanisms. So this paper is aiming at analyzing the difference and the details of them, especially explains the design principles and the technical background from the standards point of view. yeah, so since all of the authors were involved in the 3GPP activities where these mechanisms are developed. So yeah, this is the main purpose and content.
Okay, great, thank you. And when we talk about authentication and authentication mechanisms, perhaps you could talk a bit about specifically what we're talking about there, a bit further.
Yeah. So
yeah, sorry, Taka, please.
Sorry, go ahead. Yeah, please.
I was going to expand to what Philippa was saying. So maybe somewhat it could also be like what is the purpose of different authentication mechanisms and things like that. I guess that's what you're also leading towards, Philippa.
Yeah.
Yeah, so in mobile systems, when we say authentication, we are talking about what's called AKA, Authentication and Key Agreement. So as the name suggests, there are two parts. One is the authentication, and the other one is a key agreement. So the authentication part is basically the mobile system that verifies that you are the legitimate user and you have been not a fake user and you have been paying all the bills monthly correctly and your mobile phone is not stolen or lost. So based on that, once that those checks are okay, then the mobile system core network initiates the key agreement. In the key agreement, essentially both mobile phone, UE, and the core network establishes the session keys. When we say session keys, it's not just one key, but actually the multiple keys for different purposes. So if we, let's say, picture like a two-dimensional table in your mind, one dimension is the control plane, the other one is user plane, and the other dimension is the encryption key and integrity protection key. So you have combination of those four keys for each of those purposes. So that's the 2x2 table. The four keys exist for the what's called the access stratum. Access stratum is the connection between your mobile phone and the base station over the radio connection. That part is protected, both encryption and the integrity protection, and in both control plane and user plane. And in the non-access stratum, what we call NAS, that's the control plane connection between your mobile phone and the core network. And that part has only because there's only a signaling, we have only two keys. One is for the encryption and integrity protection. The encryption key is used for encryption, obviously, and that's there to make it secure. I mean, it's not the content is not visible to anybody outside who doesn't have the keys. So from outsider's point of view, the content of the message looks just garbage, gibberish. Integrity protection means that your content of the message is not altered by anybody. So you create a message and send it, and then it arrives to the end of the connection intact. So that's the key establishment part. So those two parts, the authentication and the key agreement, those are the two components of this AKA procedure.
Okay, thank you, Taka. And the paper itself is looking at authentication within 5G. So kind of what are the different types of authentication specifically possible in 5G, and what are their purposes?
So I guess that was something I was trying to ask as well. Is you have talked about primary, secondary, slice, application related ACMA and stuff. But to explain to common public, to everyone who might not know, can you differentiate these in some simple terms?
Sure. Yeah. I can try to explain the purposes of those authentication mechanisms. So first, as Taka mentioned, which is primary authentication, and AKA is to achieve the primary authentication. So basically, the primary authentication is trying to achieve the mutual authentication between the user equipment and the mobile operator's network. So it is a very fundamental feature that we have in the mobile network to ensure the security of both the users and the operators. So for example, the operator needs to ensure only the authentic users can access to the operator's network, and only those users can have that have been authenticated successfully can use the services like calling, messaging, surfing the internet that the operators provide. So this is to ensure the operator's network are not be attacked by the malicious users at a very basic level. And at the same time, the users also need to authenticate the network so as not to be deceived by the fake network. So this is the how the primary authentication works, and we've had it for several years since 2G in the mobile networks. And on top of that, we also have secondary authentication, which occurs between the user equipment and the data network outside the mobile operator domain. So usually the data network can conduct the access control by themselves without the support of mobile operator after the user plane tunnel has been established between the user and the data network. But this may allow malicious users to invoke the authentication service provided by the data network, which results in a denial of services attack. So with this risk, secondary authentication is designed so that the mobile operator is involved in the authentication procedure of the data network and the user. Only after the successful authentication by the data network to the UE, so the operator can provide user plane connection for the UE to get access to the data network. So this is, not only helps the data network provider to have control of their own authentication, but also mitigates the risks of the DOS attacks by establishing the PDU session after the successful secondary authentication. So and then another type of authentication is the slice-specific authentication. We all know that 5G introduces the concept of slicing, which is kind of a logical network resource that provides specific network capabilities and characteristics. So the slice authentication is to enable the third-party application service provider hosted within a AAA server to authenticate the end user to access its own slice. Without slice authentication, unauthorized users may consume resources of the network slice, which can also lead to DOS attacks for other legitimate UEs. And the last one we have is we call it ACMA, which is designed for the application layer authentication with the help of the operator's network. So one of the problems for the IoT application providers is that the IoT devices may have limitations in applying the traditional authentication mechanisms like username, password, which is very common in internet-style authentication mechanisms. And also an IoT device may lack resources in storing or processing certificates, or may not have provisioning interfaces such as GUI. So therefore, how to ensure the authentication between the user and the application server is problematic, especially for IoT scenarios. Actually, 3GPP has defined some bootstrapping mechanisms that the application provider can delegate the operator to achieve authentication and key distribution in the preceding generations like GBA and BEST. And ACMA is very similar with these mechanisms. And in addition, it has also some enhancements of adapting the SBA architecture and being IoT friendly. So yeah, more technical details can be referred in our paper. Yeah, thanks.
I was just thinking, Sheeba, you have anything to add to it?
As Xiaoting has very well narrated the different set of authentication possibilities that are supported in the 5Gs, I think maybe we would like to also look into the basic differences or the add-ons on top of 4G in terms of authentication mechanism. What is the add-on that we would like to see in 5G that brings more enhancements in security? I think I can give few perspective on that regard. For example, if we take the 4G, where the EPS is actually used as the authentication mechanism to enable this mutual authentication, where essentially the UE and the mobile management entity, mobility management entity, which we call as MME, that acts from the serving network, and then comes the HSS at the home network. So these entities actually facilitate the mutual authentication between UE and the network. So if we see 4G, the MME will be able to get more than one authentication vectors from the HSS. And this need to be essentially recorded or stored in the order of the synchronization numbers. If not, if it is not handled in that way, and then it may lead to synchronization issues due to out of order usage of this AVs. And in 4G, actually, the verification of the UE is done by the serving network. So there is no means the home network will be able to know whether an authentication has been successfully performed or not. And on top of these things, the UE is allowed to send its IMSI, which is the permanent identifier, in clear text. And for example, when the UE sends an attach request, it can either use its permanent ID in clear text or the temporary IDs. So allowing sending of permanent IDs in clear text may allow tracking of users and lead to privacy related issues. So these aspects are very well handled and addressed in 5G system. So in 5G system, we have actually introduced additional functionalities in the serving network as well as in the home network, like on top of the AMF, which is actually equivalent to the MME in the 4G. On top of that, we have this security anchor function in the serving network. And in the home network, on top of UDM and UDR, which does the purpose similar to the HSS, we also have an authentication server function called AUSF. So these type of additional functionalities actually help to introduce more home network control. For example, in 5G, to facilitate authentication, only one vector at a time will be able to will be fetched from the home network by the serving network to perform an authentication. Likewise, when the UE needs to send its ID, it is essentially those ID have to be confidentiality protected. For example, we have in 5G this concealing factor or functionality, which helps the UE to encrypt the ID, which we call as subscription unique concealed identifier. So the permanent identifiers need to be concealed before it is sent over the air. So at the home network, also we have this SIDF functionality which is being offered by the UDM, which helps to deconceal and utilize their identifiers to fetch as a related subscription and to run suitable authentication methods. Because, for example, we have in 5G two mandatory methods like 5G ACA as well as ePACA Prime. Based on the subscription, any one of this authentication method will be run to perform the mutual authentication. And on top of these add-ons or enhancements for security, in 5G we do also have the UE authentication verification will be performed both by the serving network as well as by the home network. So this actually gives increases the home control, because the home will know whether the UE is successfully authenticated or not, and the UDM will manage the authentication status data related to the UE. So no serving network can involve in giving wrong information to the home network. Just in case, like if a UE is not being served by a serving network, then that cannot be claimed to the home network. So we have a lot of security enhancements that has been handled in 5G system. And maybe one more feature, if I can say, for 5G system as an add-on is the ABA, is the anti-bidding down architectures related support is there, where the serving network, the CIF, actually sets this ABA parameter and it provides to the UE during this authentication message exchange. So this ABA is also bounded to the AMF key generation. So like Malaysia's UAEs are Malaysia's intervening entities cannot bid down from a higher security, a higher release security feature to any lower security that are offered by lower releases. So this anti-bidding down protection is also very well handled. And last but not the least, in 4G, after a successful authentication, we will end up with a key called KASME, which is actually the intermediate key, which actually will be used as the base key for all NAS keys and the AS key. In 5G, there is also level of segregation that was brought in the key hierarchy, where we introduce serving network specific key. Like after the successful primary authentication in 5Gs, we will result in key called KAUSF key, which is equivalent to KASME. But then the home network will generate a dedicated serving network key called anchor key, which is also called as KCIF key. This key will be holded by the serving network to generate NAS key and then the AS keys. So sufficient cryptographic separations are reasonably handled to ensure like more secure service will be provided to the UAE. Yeah, so I think in 5G, the security features have been very nicely developed and taken care on top of 4G systems.
Okay, thank you, Sheeba. And it was interesting to hear kind of how such mechanisms develop from 4G to 5G. But what are your thoughts on enhancements and the direction of this in the future? Sheeba, if you'd like to give your thoughts, or anybody else?
I think for the future direction, from our side, we are looking into more like currently the 5G already started looking into provisioning more on-demand services and temporary subscriptions or service provisions, like localized services for localized services. Even for the case when the UE does not have any subscription, it is expected, like we have use cases that needs provisioning of temporary subscription. So in this evolution, setting up the initial trust between all the stakeholders and the UE is a more challenging part. Basically, to for any end user to fetch to activate a subscription, to buy a subscription and to activate a subscription related to any service, we need to take care of identity verification. For example, that is done over verifying the passports of the end user initially to activate a service, and passport or any ID card, country ID card. So if these identity verifications actually happen with the help of third party who check the government databases to initially verify the identification. If any forging happens at these premises, then it can lead to more serious issues, like it can impact the reputation. Also, it is more a serious issue for the end user, where the end user's data will be forged and mishandled by any other malicious party. So here, setting up the initial trust is really a big challenge. At least in our research that we are looking for the future generations, we are looking more into a decentralized platform, which actually helps to manage and handle data with the help of multi-party verification and consensus mechanisms. So which actually helps to ensure non-repudiation of data. And so we are looking more into having a decentralized platforms like blockchain and distributed ledgers to establish this initial trust in the future, for the future direction, I would say.
Xiaoting, do you have any further comments on the direction in the future of future research you're working on?
Yeah, from our perspective, I think since we talked about the authentication, and which is a very most important capability in the mobile operator networks, and you know that now 3GPP has evolved into 5G advanced. Also, we call it 5.5G, and also the industry has already done the research work about the 6G security. So regarding the authentication, maybe in the future network, so I think it can be summarized in two keywords from my perspective, so which are integration and lightweight. So about integration, you know that the future network is expected to provide coverage expansion, covering the satellite access. So how to ensure the traditional network that we have can authenticate the satellite user equipment, or how the mobile network integrates the authentication mechanisms of the satellite network is a problem that we are doing research on. And another aspect is about lightweight. So considering the massive diversity or concurrency of sensors, which may access the network frequently in the future, we need to ensure the lightweight access authentication mechanisms to enhance the energy efficiency and to reduce the signaling overload. So I think that is the two main research direction that we have so far. Yeah.
Okay, thank you. And unfortunately, we're kind of coming to the end of our time, but Anand, perhaps you can just finish with some thoughts on why you chose this as one of the best papers for 2021.
So first, and I should have said in the beginning, but now congratulations to the authors, so Xiaoting, Taka, Sheeba on this great paper. Just a couple of points. Of course, the paper is well written, and the importance of it as well. As is mentioned here, authentication is key to mobile communications business as a whole. You identify the user and then, or subscriber, actually subscription, and then based on that, the whole economy works. Yeah, and they have very nicely shown how all kind of authentication are there for different purposes of 5G, the regular mobile phone to IoT devices to applications and slicing and things like that. So, and at the same time, but that's not just enough to write something nicely and explain it nicely in its use. but the interest by the people also is amazing. I mean, we got so many people interested in this paper, reading this and referencing it as well. So with all these things together, this paper obviously was was the best for 2021. So congratulations and thanks for publishing this paper in the journal.
Yeah, thank you.
Thank you so
Great.
much.
Many thanks.
Well, thank you so much, all of you, for joining me today. And once again, congratulations on the best paper from 2021.